So in the previous class we have understood what is meant by DAC, right? So in the DAC there are two types, that is binary weighted resistor DAC as well as a 2R ladder DAC. So those two types are done, right? So in today's class we will try to understand what is meant by ADC, right? So ADC is nothing but analog to digital converter. So it is just the opposite of DAC. So whatever the concept we have understood in DAC, the same concept but in a reversed manner. Okay. So in the DAC we are giving digital as an input and analog as an output. So but here it takes the analog as input. It means ADC. Okay. It takes analog as input and gives digital as output. Okay. So this sentence is very important. Okay. And the functional diagram of ADC. This is the functional diagram of ADC. So here you will be providing, towards the left side you will be providing the analog input and which is represented as Vin. Okay. And towards the right side you will be getting the output and that will be in the form of a digital form. Okay. Here you are providing the analog input and here you are receiving the digital output. So here we are providing the two signals, that is a start as well as EOC. Okay, the two different signals we are providing to the ADC, start as well as AOC. So as the name specifies, whenever this signal is enabled, whenever the start signal is enabled, it will initiate the conversion. Okay, whenever the start signal is active or it is enabled, it initiates the conversion. Whenever EOC is enabled, it will not be enabled from the user side. So once the conversion is done, the EOC signal will be activated. It says that end of the conversion. Once the conversion has completed by this ADC, so the EOC will be updated. It will be acknowledging the user or it will be stating the user that the conversion is completed. And here you will be getting the digital data represented as B1, B2, B3 till Bn. This is a general diagram. So therefore we are writing Bn. And what about this? We have to give a reference voltage in order to make the ADC to work. We have to supply some power supply, right? So that's why we has to provide a reference voltage and that is represented by V reference. So this is a functional diagram for ADC. I repeat once again, there are two signals, that is towards the left side there is an analog input signal, towards the right side you will be getting the output signal which will be in the form of a digital data, and again the two extra signals, whatever here it is there, start initiates the conversion from analog to digital, and EOC, the end of conversion, all the abbreviation you have to make a note, end of conversion will be activated once the conversion is completed. And again in order to enable the whole device we have to provide the power supply which is represented by V reference. Okay. And again so in the DAC we have seen two types, and in the ADC also we'll be seeing the most important techniques, that is a flash ADC as well as a successive approximation. So we will try to understand the successive approximation little bit later. So first, so if you want to design this flash ADC or flash comparator ADC, it is called as what? Flash comparator ADC. So if you want to design this, what are all the components are required? First of all, you require the resistors. Okay, the resistors are represented here, and you require the comparators, and the comparator will be in this form. Okay, so it is a triangular, which is like almost like a triangular form, and there are two inputs towards the left side, and towards the right side will be getting the output. Okay, I'll just explain how this comparator will actually work. So this comparator is having the two terminals, that is called as a positive and negative terminal. Okay, so it is unlike the op-amp. It is somewhat different. Okay, don't just compare the op-amp that whatever we have discussed in the previous class for our binary weighted resistor. So this is a comparator and that op-amp is completely different. So it is also having two terminals, that is positive terminal as well as a negative terminal. So VA means what? Analog voltage. Okay, VA means analog voltage and VR means reference voltage. So basically what does the comparator meaning? Comparator means what? It compares the two quantities, right? So here we are providing the two quantities. Okay, so one quantity is to the positive terminal and another quantity is to the negative terminal. Okay, so the comparator means it compares the two quantities. After comparing, it has to give some output, right? And that output is represented by X. Okay. So we'll try to understand by looking into this table here. So input voltage and logic output. Okay. So the input voltage and the logic output. Now comparator, what I told, it compares the two quantities, right? So if VA is greater than VR, if this quantity is greater than VR, what will be our output? Either it will be 1 or it will be 0. Okay, it is very easy to remember. So if positive is greater than negative, you will be getting it as 1 here. Okay, that's what. If VA is greater than VR, then X value will be equal to 1. You can easily remember this. Next, if VA is less than VR, then X is equals to 0. If negative terminal is getting a highest quantity than a positive terminal, then I can tell that my output is equals to 0. Okay. Next, if VA is equals to VR, if both the quantities are same, okay, if both the quantities are same, then my output voltage will be having the previous output itself. It will be maintaining the previous value itself. It will not get changed. Okay, in the previous value or in the previous time, if it is having 1, it will retain 1. In the previous instant, if it was 0, it will retain 0. Okay, so that is the meaning of this table. And again, these are the two elements that you are using in order to design the flash ADC. Along with these two elements, you are also using the encoder, which is called as a priority encoder. Okay, we should not go in depth what is meant by encoder and all. So encode means what? It will be bringing from one form to another form. That is called as meant by encoder. Okay, so we are using 8 to 3 encoder. So here we are providing the 8 signals and we are taking the 3 signals to the right side. Okay, whenever I am discussing the whole diagram of the flash comparator, at that time you will understand how that priority encoder will actually work. Okay, so right now, what are the 3 important elements that we are using in order to design the flash ADC? We are using the resistors, comparators and also the priority encoder. Okay, encoder means it encodes from one form to another form. So we are using the 8 to 3. Okay, 8 is to 3 encoder we are using. 8 is to 3 ಅಂದ್ರೆ 8 input signals ಇರುತ್ತೆ, output ಅಲ್ಲಿ ನಿಮಗೆ 3 signals ಇರುತ್ತೆ. Okay, that is the meaning of 8 is to 3 encoder. So these are the 3 important terms we are using in order to design the flash ADC. I hope you people are clear with these concepts. So what are all the things we have discussed? What is ADC and what is the functional diagram of ADC and what are the important components required in order to build the ADC, I mean the flash ADC, and how the comparator